Don't forget to like and subscribe.
It's Jim Keller, everybody. It's George Kozma, everybody.
It's Ian Cuttress, everybody.
Oh, you full of turkey?
No, actually, pierogies.
No.
Pierogies and steak.
You see, in the UK, it's our Christmas is the one that has the turkey because we don't have Thanksgiving, so Christmas is our turkey bird. I am very full of turkey.
Well, that's good.
Well, it seems that we bought a turkey and ate it before Christmas, or managed to finish it before Christmas. So I had to buy another one on Christmas Eve. You know, your bog standard roast in a tin covered in bacon. Throw in a bulb of garlic, cut in half, and away you go. It's very nice. Cats like it as well. But yeah, I've actually had a relatively sedate Christmas. So how about you? I know you've been family.
I was doing cooking. I was helping with the my family makes what's known as batter nuts, which are sort of like beignets, kind of.
Okay.
We used to do a version called, we used to put raisins in them, which we called misers, but my mother doesn't like that, so we just do the batter nuts without the raisins. Okay. And then my mother decided to make what's known in the family as soup with balls. It's literally chicken soup and I don't know how to describe the balls really, other than they're like fried bread, essentially.
You mean fried and breaded?
No, I mean like fried bread.
Oh, so you just put fried bread in it?
Kind of, but it's different. It's like little fried dumplings, essentially. I can't really describe it.
I was going to say, you put fried bread in liquid and it's going to for that long and it'll dense up and become dense. Yeah. So yeah. So what you're saying? I was about to say, well, that's vegan, but then I realized no, that's chicken soup. Yes, it's vegan. It just has a little bit of the chicken. You'll be fine. Just a little bit of the chicken. No, it's I got a very nice case of sour beer as well for Christmas. So, and I've been slowly going through that wine gum flavor. You don't know what wine gums are, but
sounds vaguely familiar.
The idea is that it's chewy gummy candy, but they're meant to be a bit more upmarket.
Oh.
And they traditionally used to have names on them of different wines like Merlot and whatever.
Oh, okay. Maybe I have seen these before.
You might have seen them. I don't think you've had them before. But this was wine gum flavored sour beer. Also have cotton candy, or candy floss as we call it.
Yeah.
And this is not a promotion, but if anybody is in the UK and wants some good sour beer, I highly recommend these guys. Vault City. I read a thread on Reddit last week saying, "Has Vault City ruined sour beer for you?" And the premise was, it's so good. But they've ventured out into doing low alcohol versions and stouts as well. But yeah, we have Toblerone flavored stout, and they do peach cobbler. Here, here's the beer gums. This is the collaboration, sold out.
Botlewa drizzle berry cheesecake. That sounds incredibly decadent.
It's 8%, and also £8 a can.
Yeah.
It goes as low as 350. Each one is dependent. This is cocoa, cherry, and dark chocolate sour beer. This is the Ferrero
Rocher.
Without calling it Ferrero Rocher. Yeah, my wife likes to get me a dozen of these at Christmas. So I highly recommend. Oh, here we go. Wasteland Imperial.
So I don't think I've had the opportunity to show this on the show yet, but managed to snag this from the AMD booth at Supercomputing.
Is that a Lego mock-up?
Yeah, it's the Lego mock-up of the MI355.
Oh, nice.
So,
as in, did you take a kit or was that pre-assembled?
No, I took the kit and assembled it myself.
Okay. It's the going thing now with companies and event freebies is you got to have the Lego kit in. I don't think I've opened any of my Lego kits.
See, I like opening my Lego kits. I like assembling them.
Yeah, I mean, my Intel Clearwater Forest is over there still. I've got an AMD Turin somewhere.
Mine's over there.
I think Dell Power Edge something or other is up there.
Yep.
Along with hordes of DRAM.
Don't you mean SRAM?
No, it's DRAM.
One of these days I'm going to buy some SRAM just to mess with you.
It's for those of you who are following all this stuff about DRAM pricing, and our good friend Vikram over at Vic's newsletter, he did a small primer, but one thing here is you can't source SRAM from a supplier. It is built on chip. George's point is you used to buy SRAM. Back when you could increase caches like that. But no, it's that's not how we do things anymore. Okay, as people are rolling in, thank you, chat, for coming on board. Hopefully you're not too wasted or exhausted from family. But today we've got a really interesting show, and this has been blowing up. What we're going to talk about is some of which has been blowing up my inbox recently. But hi, everyone, and welcome to the Tech Routine, the weekly podcast where we talk about processors and silicon and how we've taught very special rocks to think in very special ways. We're called the Tech Routine because my name is Ian and I run a channel called Tech Potato, and my co-host, as always, is George from Chips and Cheese. If we had a guest, they would be the gravy, thus making a lovely tech routine. Also, if we had a sponsor, here's where we might put it. If you do wish to sponsor the show, then please do let us know. We do accept and read super chats made by our listeners and watchers, but only if they don't demonetize the channel. And the show usually lasts a good couple of hours, sometimes more. But if there's time, we'll stick around and we'll get to some Q&A. But today's first question is, George, how are you doing?
Good. So I actually got a Christmas present from our friend James. I got a tin of cheese.
Oh, is this the Mook cheese?
No. This is what's known as Cougar Gold cheddar cheese, which is a specialty of Washington State University, and it comes shipped in a can. Because back in the 1940s, 30s and 40s, the U.S. government was looking into ways to preserve food. And, well, traditionally with a can, you see like cans would expand, and that's bad. So they developed a special way to preserve the cheese in the can.
Sounds like spam to me. Sounds like spam. But so we have a few really interesting topics to go through, but the first one, I think, so this has been my big news, and it's right in the center here. Maybe I can zoom in and We have. Let me go through our written thing here. So, Groq and Nvidia have announced a non-exclusive inference technology licensing agreement. CNBC has reported, alongside the announcement, that it's about $20 billion, with Nvidia acquiring Groq's physical assets, but not acquiring Groq, the company. And Groq, the company, retains the IP. In an email, Jensen Huang said to his employees that NVIDIA will integrate Groq's low latency processors into the NVIDIA AI factory architecture, and says NVIDIA is licensing Groq's IP and adding employees, not buying the company. Groq CEO Jonathan Ross and almost everyone of note are expected to join NVIDIA, while Groq, the company, continues its Groq Cloud, which is token as a service, and its Middle East agreements. The structure creates immediate uncertainty over whether this is a one-time payment of $20 billion, whether the license is a lifetime, and whether NVIDIA can build on top of Groq's next-generation architecture. Another source of confusion is why NVIDIA would spend $20 billion to extract pieces of a well-funded startup whose first chip predates large language model boom, and whose second generation hasn't actually shipped yet. And so far, we've only really had conjecture and thoughts as to what strategic value makes the number make sense. Groq is one of the AI ASIC makers that has managed to raise over $1 billion since their startup in 2016. And Groq's CEO, if you didn't know, John Ross, he was what part of the team that created the original TPU at Google, first 3 generations, I believe. And in 2019, Groq released their first chip, the Groq Chip 1. They called it the TSP, the Tensor Stream Processor. Then once language came about, they called it the LPU, the Language Processing Unit. The chip was originally designed for CNNs, for convolutional neural networks, but Groq just pivoted to large language models by scaling out the number of chips rather than adding on-package memory. It means each chip only has 220 or 230 megabytes of SRAM. And to scale out to something like a 70 billion parameter model, you need at least 5 or 10 racks to do it properly. 5 racks for 8-bit, 10 racks for 16-bit. Groq's biggest customers were in the Middle East, and in January they had announced a $1.5 billion agreement with the Kingdom of Saudi Arabia, at which point John said they had already deployed 19,000 chips in the area. The first generation chip built on Global Foundries, 12 nanometer, I believe. And the second generation chip, which was meant to be out by the end of this year, because originally John said it was going to be shipping for revenue by the end of this year. That's built on Samsung 4X, SF4X. We don't know the architecture of that second gen chip. We believe it's just a bigger Gen 1 chip, but maybe with stacked SRAM or stacked DRAM, or stacked RAM, whatever. And yeah, the thing is, NVIDIA here isn't buying the company. They're getting around regulatory issues by kind of pulling, not pulling the rug, that's the wrong phrase. Just
acqui-hiring and licensing.
Yeah, they're taking everybody of note. They're licensing the IP, but they're also acquiring all the assets, or a lot of the assets, which for us probably means chips in production. The company had raised $1.8 billion total, so $20 billion. If this was a traditional exit, would be a massive 10x exit. As far as we're aware, all the investors are getting paid out of this. And some of it is also tied to performance, whatever that means. The problem is, this came on my plate at 11 p.m. on Christmas Eve, my time.
Yeah.
So 3 p.m. Pacific, 6 p.m. Eastern, just as the market's closed.
Yeah. I think everybody just went, wait, what? Why is this being announced now?
Yeah. Groq was the only one to actually say anything publicly.
Oh.
Okay. NVIDIA haven't commented yet. The only notes we have from NVIDIA are shared emails. a couple of people from Groq have already reached out to me, and apparently they will know more next week. As in, they're not the C-suite, but
yeah,
it's and you know, so this is on More Than More. This is on my Substack. I paywalled this because it was very very breaking news at the time. Right, this is a picture of me and the CEO of Groq back in September 2022. He now dresses in suits and has lost weight. Groq, one of the good things that they did over the last 3 years is marketing. They hired a guy and a team under Mark Heaps, who, funnily enough, now works for Nvidia. And he basically got Groq into everywhere and everything, got the CEO to smarten up. They were behind the Llama stunt at Supercomputing 23.
Yep, that was 23 because I was in Denver. I remember I took a picture of that and sent it to you.
Yeah, and I was like, what the hell? But then I realized that from the hotel we were at to the venue, I saw the trailer that the Llama came out of. Yeah, and so I've known Groq for a fair bit. I visited their headquarters at the time because I'd seen about a dozen presentations about their architecture, to the point where I could perhaps recite the architecture. But I just turned around and said, look, I still don't get it. And they're like, okay, come in. This was actually at Saturday. They said Saturday, 8 a.m. because I was in the Bay Area. I came in, sat me down for 2 hours. And then I realized, oh, your diagrams aren't spatial. They aren't spatially relevant. They're time domain relevant. And then it all clicked into place. This is their first gen chip. Like I said, at this point, it's 6 years old now.
Yeah, and the architecture is more like 8 years old.
Yeah, so this is the architecture. This is one of their OG slides because they call it the TSP. And the idea is that it's a very big VLIW design. And they described it as, well, the data stays still and the instructions go through it. Whatever that means. But the idea is that you have two highways, so it's like hyper-threaded as well.
Instead of data flow, it's instruction flow.
Yeah. Okay, but data is instructions. Yeah.
I was trying to make a joke.
Yeah. But yeah, they're doing 8-bit integer with 32-bit accumulate for their Macs. Like I say, this is a convolutional neural network chip. And yeah, the whole idea was 230 megabytes of onboard SRAM. But in order to make a big VLIW work, it has to be a deterministic, which means the moment you compile your kernel, you know exactly where every instruction is or every data point is going to be at any point in the cycle. And VLIW architectures are very hard to compile for, very hard to program for. That's why typically you only see them running in DSPs, digital signal processors, like camera filters, for example.
Probably the most prevalent is actually one that may be in your phone, Hexagon.
Well, yeah, so
DSP is VLIW.
Yeah, Hexagon started as a camera DSP, right? So but the thing is, with a camera DSP, you're getting image data and you're applying a filter. It's a very fixed workload, and that's why VLIW is sometimes called fixed function to a certain extent. One criticism I saw with Groq is that they would move heaven and earth to support open source models on day one. But you fast forward 6 to 12 months later, and the performance of those day one models was the same as it was on day one. And that's because if you spend your time hand coding for models, you're not creating a general use case for performance. So yeah, and to date raised 1.8 billion, like I said. So that's 640 million in Series D and 750 million in Series E, but in 24 and 25. So they were burning a lot of money, and this is one of the criticisms that Groq came under, because it's an old chip built on an old process node, not built for transformers. So those 5 or 10 racks that we said you needed, I believe this chip was 150 watts. You need something like
that, yeah.
You need something like 100 kilowatts. And so the performance per watt, because of the old design, was crazy. And so this happened, right? And the question was why? Why do you think Nvidia, for lack of a better, and Saylor also points out, AMD GPUs pre-GCN were also VLIW and competitive at the time, but again, a graphics workload, right? Again, a very fixed function sort of thing.
Yeah, the second you want to do compute, you move to a non-VLIW.
Well, it's because
GCN.
General purpose, right? Yeah. This is also the argument that Lisa puts out between GPU and ASIC. ASICs are too fixed function, whereas GPUs are a lot more flexible. I would argue that a lot of ASICs today are quite flexible for AI workloads. Not for graphics workloads, but for AI workloads. But in Groq's case, Groq initially started out also trying to sell hardware, right? It's a hardware company. And then they realized that people didn't want to change their software stack for a new piece of hardware. So they became a cloud company. Tokens as a service, basically. They set up what's called Groq Cloud, which stays under the company, under the Groq company, GROQ, not GROK. That's the Elon Musk thing. One thought was, did Nvidia do a spelling mistake and buy the wrong company? But yeah, so Groq Q, the company, basically has a cloud of compute, and people would literally use API keys to access it. They said they weren't subsidizing the cost of the tokens. They told me they weren't. However, everybody I ask says if you do the mathematics on the power consumption required and the throughput they were suggesting, they would be much more, orders of magnitude more expensive than any NVIDIA NeoCloud. But because the chips are deterministic in VLIW, their one key feature is that in batch 1, you know how long it's going to take to get to your token. Right? There's no variability in performance for batch 1. Higher batches, there's some variability. But, NVIDIA's graph that shows, peak token throughput versus tokens per user.
Yeah.
Groq was always well beyond NVIDIA on the tokens per user. Overall throughput was terrible, but that's because at the bottom, your tokens is per individual user. And if I remember correctly, NVIDIA for some popular model would get around 250, 300, and Groq was able to do more like 700 to 1,000 to 1,400. And I think even on some small models, maybe even 2,000 tokens per second. And their goal was, let's just keep pumping that because that's a use case people want. And there's arguments for and against whether that is actually a workload that's relevant. So yeah, there are certain reasons why NVIDIA might make this purchase. I'm not going to say acquisition because it's not an acquisition, purchase and licensing. Number one, NVIDIA just has too much money. I believe in their last quarterly earnings call, they had $60 billion cash on hand. And their free cash flow in because of their financial year, their net cash from operations, last quarter was almost $24 billion. So there's that. Reason number two is they might see Groq as a competitor. Spend 20 billion now to save you losing 200 billion later. That only works if you consider Groq as a serious competitor to Nvidia.
Yeah.
And based on the hardware, I don't think anybody thought so. Groq chip 2 or Groq chip 3 may be different, but we don't know those architectures.
Now, so I put a little bit of what I speculated in here as, but 20 billion does seem very steep for this. If this is in fact what the major reason why, so I think this may be like tangential or secondary. So Groq's architecture is very good at CNNs. And something that NVIDIA has, it has open source, at least the first version of, is something known as NVDLA, or the NVIDIA Deep Learning Accelerator. This is essentially NVIDIA's NPU. It's found on something like this, an Orin Nano. And I suspect that we may see Groq IP used as a replacement for the NVDLA.
Why?
So that's sort of my thing, is that I can't figure out why else, like what else would you?
It's in my discussions with investors so far, they've been trying to pinpoint what value comes out of Groq to get to 20 billion.
Yeah. And
replacing the NVDLA on a Orin Nano is not a $20 billion market.
Well, so the thing is that you mentioned batch 1 determinism that could be useful in the automotive sector, maybe.
So part of this, and I didn't write it in my article, is why wouldn't NVIDIA just build their own?
Yeah, that's sort of my issues. I'm sort of, even with this whole DLA thing, I'm stretching.
And even if they could build their own, a VLIW, and they don't have the compiler team, right? Because VLIW compilation is very difficult, and all they're doing in this acquisition is acquiring the compiler team for that. That's not a $20 billion purchase.
No.
And yeah, so it go. But my thoughts go on a little bit more. Groq's lead architect when they started was a guy called Dennis Abt, ABT, and he was at the company for 5.5, almost 6 years. He left to join NVIDIA a couple of years ago, as one of their distinguished research scientists. So who knows? Maybe he's been putting some of the building blocks together to integrate Groq into CUDA, which is another thing. So
maybe, but
yeah,
I don't know.
And thank you, Safi, for the £5. He says sponsor enters. Thank you. So yeah, one point here is just simply, could Groq's chips, as they imagine Groq chip 2 is just like Groq chip 1 but scaled, and maybe with a bit more memory. Could they fit into NVIDIA's silicon ecosystem? Right, a modern, if you take like an NVL72 Blackwell rack. I think I read there's 7 custom pieces of silicon that NVIDIA make that go into that. Right, if you did a Groq version of it, or you had a Groq version, you know, like CPX. NVIDIA just announced CPX, which is the DRAM. It's a compute focused rather than memory focused chip, because it uses GDDR, not HBM, which is lower cost for prefill. Yeah, but it's designed for compute bound AI portions of the workload, not memory bound. Which in inference you have prefill and decode, and it's prefill that's compute bound and decode is memory bound. So the idea is that you do the prefill on cheaper chips like the CPX, and then you do the expensive stuff on the expensive stuff. Would there be an ecosystem where you could put some Groq chips in there as well for different parts of the workload. One, you have to get your software to recognize Groq chips, which is harder than it sounds. Two, what part of the workload ecosystem
would benefit
that much, and that could be at that scale. Maybe somebody at Nvidia has said, well, if we take this chip and we iterate on it for 5 years to the point where it could be a partner against, you know, whatever Rubin, Feynman, whatever is in 5 years, we can get something that's that diagram. Even though we use Dynamo and get all the parallelism, we can hit 20,000 tokens per second, but it's called an Nvidia chip. It's a little bit crazy. It's if somebody's done some market research, if this is what they want to do with this, you know, acquisition, purchase, then somebody's done some extreme extrapolation than based and knows more than what we do.
Yeah, I don't, unless they consider the people there that good. They could be. I don't know. I haven't really interacted with the Groq folks all that much.
So I've got another point here, and that just says VLIW. And okay, so George, who are Nvidia's biggest competitors in AI hardware?
So the biggest, I guess, mainstream in quotes competitor would be
just anyone.
AMD.
Yep.
Cerebrus.
Nope.
Well, okay, then the hyperscalers.
Yeah. So Google TPU.
Yeah.
And Amazon Trainium.
Which, as far as I understand, is kind of Google TPU at home.
Well, so the thing is, right, Google's TPU is a systolic array architecture, but it's a VLIW systolic array.
Yeah, it's VLIW SIMD, which is funny to think about, but
so that's an 8-way VLIW architecture, which is, you know, in DSP lands, that's actually quite common. 8-way VLIW. The Sega Saturn DSP, for example, was a 6-wide VLIW, which is funny to think about. And
I have another VLIW architecture.
Yeah, Itanium. Yes. But the thing is, Groq's architecture is 144-way VLIW. So maybe this is the way that Nvidia gets onto the VLIW train.
So that's the funny thing, right? As far as we understand, Volta and Turin were VLIW under the hood.
Turing, not Turin.
Sorry, Turing.
Yes.
It's just a G at the end.
Yeah.
But yeah,
so the other angle in this is NVIDIA is also going through this sort of, we want to push NVLink Fusion everywhere. We want to push NVLink everywhere. We want to work with companies to put our IP in their chips. We also want to put chiplets out there to enable this, so that they can use our NVL72 backbone and expand. So perhaps this is just another chip that they can put into that ecosystem. But again, who wants it? Who would want it? And why?
Unless this is some sort of weird, like, Middle East or China play.
Right. So one of my points on my post was, it would make sense, this purchase, if Nvidia saw Groq expanding in the Middle East quite heavily and said, actually, we want that business.
In which case, yeah, they could be worth $20 billion just for that.
But that stays with the Groq company. That's not part of the deal.
Yeah, which
so
yeah,
so many.
If they just wanted the business, then they would have bought the other part that they aren't buying for 20 billion.
The thing is, Nvidia kind of did this a few weeks ago with Fabrica, which is a networking company, even though they have Mellanox.
Yeah.
Right under the hood.
Mm-hmm.
It's that, you know, they have InfiniBand, they have their own Ethernet switches.
So
the idea was
sort of going to sort of a tangent. It's a similar thing happened about 2 weeks ago with SchedMD, which is the main developers behind.
We'll get to that.
Well, no, because they also bought Run AI, which is again a very similar thing to Slurm. So
is this vertically integrating? So thanks, Jay, for the $20, and yes, and also the wealth. However, how much DDR5 you have in your drawer? Yes. Now, one of the conclusions I had is we all expected that this ecosystem to have some consolidation at some point, right?
Yeah.
The thing is, I've always said that above a certain fundraise, you become unacquirable, right? And my fundraise limit for around that was about 400 million. So you wouldn't expect a $1.8 billion company to be purchased. Because the only company that can do that is Nvidia.
Yeah.
Or I guess Apple or Microsoft or Google.
Or Meta.
Or Meta. Well, Meta already did. They bought Revos.
Yeah.
Not Intel anymore. I don't see AMD buying anybody like that.
No.
It's the
they would buy a smaller startup or Xilinx.
The thing is, what makes this so one of the words that's being thrown around is acquihire, right?
Yeah.
All this, as far as we know, most of the senior team and anybody of note at Groq is going over. Which leaves obviously Groq, the company, as well. Are they going to iterate their IP? Does Nvidia get the rights to iterate on the IP and fork it and do their own thing? Again, that's not, we don't know the details, excuse me, of that. But it's just it comes down to how much of Groq is worth 20 billion.
Because if you think about it from this perspective, that's about half of what they were willing to pay for ARM.
Yeah.
And it's I don't see what's worth 20 billion there, unless Nvidia knows far more than either of us with regards to what technology Groq has currently or is incoming.
Well, how long was the acquisition of Mellanox? Was only 7.
Yeah.
And they're making twice that a year now in networking.
Yeah.
They're making like 15 billion a year from networking.
Something like that.
I mean, I know that's mostly Ethernet. And that's maybe why Infabrica was, again. Oh, in fact, yeah, again, if Infabrica wasn't acquired, although that's what I was saying, acquihire. Okay, so even if they had 1,000 employees, that's 20. What is that? 20 million per employee. Now, one external thing out of all of this has been postulated is that some of Groq's investors are tied to the US government. And this is a way for Jensen to get preferential treatment to sell GPUs to China.
I hate how much sense that makes in this administration.
In this administration. I don't think it's that. It seems far too convoluted and far too much money for that. And this is what boggles the mind. It's just the amount.
Yeah, if this was 1 billion, 2 billion, okay, sure.
But 2 billion would be a poor exit, and Groq would argue
Yeah.
they would have a couple of years of run rate left.
Sure. But my point is, if it was like lower, right? If it wasn't
$5
$20 billion, yeah,
If it was
five,
5.
right? It would make a lot more sense than 20 billion.
To be honest, 5 would still bring up question marks, given Mellanox was 6.9.
Yeah. I
And
don't know.
This is what all the investors, and I've also had other startup incubators, because Groq was a Playground Global company, I think, because when I visited Playground Global, they had a portion that they were renting from them. Yeah, no, so some of the other startups pinged me and said, how what valuation? Yeah, huh?
Basically, what?
And it's like, can we also sell our startups to Nvidia for 10x exits? Because we think we've got better value props than Groq.
Yeah. Okay, do we know how much AMD hired the Untether guys for? Was that ever disclosed? Because that's the closest thing I can think of. Granted, they didn't get the IP.
So I think so. Untether also had 130 mil in debt. So you would have assumed that they may have paid off the debt. Okay.
Because that's sort of like, granted, Untether wasn't quite as large, or at least prevalent, as Groq was, but they were one of the major ASIC companies, at least for edge applications. So,
but again, it comes down to the fact that Groq had such a stellar marketing team.
Yeah.
Right. Groq knew how to put themselves out there. They knew the right things to say.
Yeah.
And they got on the cover of, they got into Bloomberg, they got onto Wall Street Journal, they may have been mentioned in Time or something. And it means the CEO ends up having to do a lot of work back and forth, meeting people. And it's what big AI company today doesn't have a face? As in, doesn't have a person. Exactly, right? You could argue Broadcom. But it's between Hock Tan and Charlie Kawas.
Yeah, but also the thing is,
Broadcom's a different sort of business anyway.
Yeah, is Broadcom really an AI company?
Right. The hyperscalers don't really have individuals that they put front and center.
Well, you could argue they're CEOs. And
yes,
they're all fairly prevalent CEOs. So,
so AMD has Lisa.
Yeah.
Cerebrus has Andrew.
Nvidia has somebody, Jensen something.
Yeah. Tens Torrent has Jim.
Yeah.
It's New Reality has Moshe. Next Silicon has Elad.
Qualcomm has Christian.
Yep. Again, the CEO.
Yeah.
So it makes sense for companies in this space to have a visual head, or at least somebody of importance.
Mm-hmm.
That's leading the charge, and which means you need Thomas Summers of Positron AI. He's gone back down to CTO because he doesn't want to do the visual stuff.
That's understandable,
right?
The visual stuff can be hard,
especially if you're an introvert engineer.
Yes,
which most of these people are. Let's be honest.
Yeah.
So it makes sense to have a visual face out there to do a lot of this promotional work, because that gets you noticed. No, notice is a weird word because no doubt there's people at Nvidia who are tracking the same companies I am.
Yeah.
Right.
It would be shocking if they weren't.
Right. It would make more sense for Nvidia to acquire a co-packaged optics company.
So light matter or IR.
Yeah. Wouldn't it?
Yeah. I mean, yeah, because AMD got NO Semi.
Yeah. Well, okay, so I actually found a big source of confusion with Nvidia and optics recently. What Nvidia calls co-packaged optics is what the rest of the industry calls onboard optics.
Yeah.
What the industry calls co-packaged optics, Nvidia calls 2.5D optics. Why? Because it sounds like they're ahead. Yeah. So fun times on that. So we do have some discussion questions here. Does the deal signal confidence in Groq's next generation architecture or concern that Nvidia needs options outside its roadmap?
I don't know. Like legitimately, I'm.
But part of the difficulty there is it's been so long since the second gen chip.
Yeah, or first gen chip. It's like
first, yeah, from the to the release of the second gen, and Nvidia is this yearly cadence. You don't see anything knocking it. You only see additives. Could there be a situation where some of Groq's architecture goes into a Blackwell type design in the future, a Feynman or beyond Feynman?
That seems unlikely.
And it seems unlikely because Groq is a deterministic design.
Well, it's not even determinism. It's
SRAM only determinism. It only works if you have all the data ready to go and no caches.
Yeah, it just doesn't.
So, okay. So from a market perspective, does this look like strategic foresight or an expensive way to remove a potential competitor before it scales? I mean, if Nvidia is going to start buying competitors just to get rid of them,
yeah,
right? That's one. I'm pretty sure the shareholders would prefer you to do share buybacks,
yeah,
or raise the EPS, or
yeah. Blowing raspberries, Jay, was what that was.
Yeah.
But I because also I will say that if they do start buying competitors, like if they go and buy Cerebras and Sambanova for whatever reason, right? If they start buying these large startups, like that is worrying. Like that's worrying to me.
I mean, like I said, it's part of the consolidation of the market is that always happens, right? It's funny. Did you see what Scar Greek said?
Yes.
They only got the trade.
Funny.
They only got the trade. The thing is, let's see if I can bring it up here. Something I found out a while back.
Also, as a reminder, they probably got the trademark in terms of like their font or like.
No. Guess who had the trademark Groq in 2016?
AMD.
AMD, baby.
Yeah.
Right. Let's put this up at stage. Here we go. Yeah. So this is the trademark page for Groq, Groq. Trademark application was refused. Also, they didn't even have it. They just filed for it.
Huh.
And yeah, AMD down here. They filed in 2016. And the application was abandoned in 2018.
Because it looks like it was never really used.
Yeah. Wait, do you have to use a trademark before you get it?
So trademark is funny in that you do get an implicit trademark.
Yeah.
But usually companies will trademark something before they use it, but they may not for whatever reason, and then rely on the implicit trademark until they get a product out. And day of product release, they'll then send to the trademark office a request for the trademark.
Yeah.
Trademark law is funny like that. So
what? Something popped up and I've just now lost it. Damn it. If you ever want a fun search, go search for AMD's old trademarks. AMD changing the game.
Does
6,000.
does Nvidia hold the trademark on the way you're meant the way it's meant to be played? I can never remember if they do or not.
Yes, they have done at some point. Funny enough, AMD applied for the trademark True North.
Ha!
In 2003.
That's funny.
And it was the application was abandoned because the applicant failed to respond. Does to True North, all one word. So, yeah. So yeah, when it comes down to Groq,
I don't know.
We should know more next week.
Hopefully. Hopefully.
We'll get later on to talk about CES.
Yeah.
Because Nvidia is going to be presenting there. But do you want to talk about SchedMD?
Yeah. So Nvidia bought.
You can go through the prepared.
Yeah.
So if you want.
SchedMD, which is the main developer behind Slurm, Nvidia announced that they have acquired SchedMD, which is a Utah-based company, and it is the dominant open source workload manager and is used on the top 10 and on the majority of top 10 and top 100 supercomputers in the world. The deal and valuation wasn't publicly disclosed. NVIDIA has said that Slurm will remain open source and vendor neutral while accelerating its development across HPC and AI workloads. SchedMD was founded in 2010 to develop and support Slurm. Slurm coming actually out of Lawrence Livermore Labs and a couple other companies. SchedMD was founded to become the caretaker of Slurm and to commercialize it.
A for-profit company.
Yes. No, it's actually a non-for-profit company.
Okay.
It was a non-for-profit company. And some in the HPC community, some here, some in this chat have voiced skepticism, fearing that even if the code does stay open, NVIDIA's control over this very critical software layer could influence priorities and hardware optimization, along with the neutrality of job scheduling in mixed environments.
Prioritize NVIDIA.
Yeah. People point to past acquisitions and the community sentiment about vendor lock-in and sort of just how vertical NVIDIA is going with some of this. And it does raise questions about the long-term governance and ecosystem competition.
Well,
now, I know that Lawrence Livermore, again, has been working on an alternative to Slurm called Flux. And I would not be surprised to learn that that venture gets accelerated by this. And what's odd is sort of getting back to that in Fabrica and Mellanox equivocation. December last year, NVIDIA bought Run AI, which is also a workload manager and job scheduler. So why are they buying Slurm when they already had an equivalence under the NVIDIA?
For NVIDIA Dynamo, maybe? But again, this is open source software, right? And NVIDIA could fork it and do what they want with it, right? I'm not sure about whether they could commercialize it, but typically you would acquire something to gain control with potential future commercialization.
Yeah, but in this case, the code is already open sourced.
Well, can they change the license on it, or could they fork it and then the fork has a different license?
Yeah, they could do that and essentially deprecate Slurm as it currently exists.
Yep. I mean, we've had big companies acquire, big software companies before. Broadcom acquired VMware, changed all the licensing deals, 3x the price, and now there's a bulk shift away from VMware. But then IBM acquired Red Hat, and that's been overall, I think, a net positive, though there have been some bumps in the road with it over time. But yeah, but to start here, I think we should point out, for people who don't sit in in this space, what exactly is Slurm and what is a workload manager?
I mean, it sort of does what it says on the tin. It basically distributes your jobs and your workload across multiple nodes. It allows you to scale a workload.
Well, it's not just you; it's everyone else who wants to use the same system.
Yes.
If you have a multi-tenant environment, you submit jobs, and the jobs are queued. They may be queued on priority, or how much you pay, or how many resources you want. And it's the workload manager's job to ensure that the data needed for your work doesn't interfere with the data that anybody else needs, but is also on a part of the system that can run uninterrupted. Or if it does get interrupted, it can restart or recover from a checkpoint. It basically multi-tenant workload management. Even though it's called workload management, it's multi-tenant or multi-kernel. It could be one team, but submitting lots of different work. So it's used in a lot of big infrastructure where lots of people need the same set of resources, or it's better to have one big set of resources and everybody enter through the same portal, that portal being the workload manager, of which Slurm is the most popular. Or Slurm powered by NVIDIA, or Slurm, the refreshing drink from the year 3000.
But yeah, I'm not a fan of this personally. Now, the counterpoint to this is that this is not actually that irreplaceable a piece of software. This is actually a fairly simple, like you could fairly easily replace this or just do a deploy in place with an open source fork.
Ooh, I hate that. Highlight something that says share this.
Oh, yeah, that's annoying.
But yeah, and Nvidia is saying it will continue to offer open source support. Does it say they'll actually continue investing in Slurm's development to ensure it remains the leading open source scheduler for HPC and AI? The thing is, HPC systems are, in terms of units, mostly Nvidia. In terms of compute, it's AMD, but in terms of units, it's Nvidia.
Yeah.
In terms of installations,
it's well.
So one thing, if you buy like a Cray supercomputer, do you get the Cray scheduler workload manager, or can you run?
So
Slurm?
they use Slurm.
Okay.
They use Slurm, which. Yeah, I don't know if this will happen because I don't think this is big enough to sort of get like.
Am I going to have to bring out the XKCD comic?
You may have to, but I don't like this. The pit of my stomach does not. Yeah. The pit of my stomach does not feel particularly good.
Settled.
Yeah.
It's always the way when something that's big and open source and loved by the community gets acquired by a big corporate company with billions of dollars.
Yeah.
Because the big corporate company with billions of dollars has to make billions of dollars.
And I know Jay in chat mentioned another company that Nvidia bought, which was Bright Computing. Granted, Bright Computing was closed source, if I remember correctly, but the license on that is not ideal, from what I understand. And as Jay says, you're right, it's not irreplaceable, but Slurm is a well-designed piece of software with a lot of support from other projects for good reason. Yeah.
Well, it's the people always say, what's going to replace silicon in chips? And then the answer is anything that can do the last 70 years of improvements in one.
Yeah.
Right. And so it's the same with these software projects. They get decades of improvements built in, and the only thing that can replace it is something that can replicate those decades of improvements, but on day one, to at least be equal. Because if it's not equal.
The good thing about Slurm being open source means that assuming Lawrence Livermore gets Flux up and running, it is actually backwards compatible with Slurm in terms of how it schedules, if I remember correctly. I don't completely understand the details of how that works exactly, but it would be a functional replacement for Slurm as far as I understand. So
yeah. Okay, cool. Let's move on. Let's move on.
Yeah.
We're roughly at the middle of the podcast here now. We don't have a sponsor, but we have merch. And so let's spend a couple of seconds looking at some merch. One thing I need to do this week is put in all the new designs that we've been doing. Because if you've been following the channel, this is the same sort of stuff that I
still need to get this keynote could have been an email shirt.
Please don't wear it at CES.
No, I'll wear it just underneath my regular shirt and with the decal on the back.
You're killing me, George. It's we got a few more designs to go up, so all in good fun. So next up, we got some architecture to talk about. And in keeping with the theme of this show being mostly about NVIDIA, let's talk about more NVIDIA. because Nvidia actually makes CPUs. And their newest upcoming core, their upcoming chip is called Vera. Vera is part of the Vera Rubin family. And this week, wait, this is dated 14th of August, but for some reason it's only just come across our desk now. We're starting talking about Olympus. And Olympus is the core, the ARM-based core that's going into the Vera CPU. And George put this on my desk and said, it looks strange. So I do have some prepared remarks here. So NVIDIA has released the first CPU optimization guide for its upcoming Olympus core inside its Vera data center ARM-based CPUs. This is the evolution of the core found inside Grace and builds on the design. This document here showcases the supported instructions as well as throughput. What interested us is that this will be one of the first data center ARM CPU cores with simultaneous multi-threading. And by reading between the lines, NVIDIA is doing things a little differently than what we're used to. The thing is, in an AMD or Intel-based multi-threaded design, the core allows each thread to share almost all the resources in both the front end and the back end. This is actually the evolution. It used to be fully static, and we're now getting to a point where we have enough transistors to make it dynamic. In Intel and AMD, there is pretty much all dynamically allocated. There's some quality of service, but the idea is that where it's resolved, where that flexibility is resolved, is in the retire queue, which is right at the end. And that's what's statically partitioned. And there's a good long-standing assumption in CPU design that if you want good peak performance in multi-threaded, most of the core has to be dynamic, and that contention is resolved late in the retire queue. Thing is, with this core, with the Olympus core, in the Vera CPU, it does it the other way around. It puts more static limits in the core at multiple stages, which you might think, oh, well, that's what we used to do before we knew how to make everything dynamic. But it looks like this is on purpose. And as a result, because you have those fixed limits in the middle of the core, it makes it look conservative, or it should end up looking more conservative in peak benchmarks. Flip side is that if you do some of the simulation, it might actually be more regular in mixed or unpredictable workloads. So the thing is, when you have a fully flexible core, if you have a peak workload, it might be the peakiest, but if you have a worst case, it might be worse than a statically scheduled core just due to contention and scale. And so the real question is whether NVIDIA is optimizing Olympus for headline IPC or for things like determinism, latency, and predictable power. And it also opens up the discussion which way multi-threaded design should go in the future, if we're talking about system level performance or data center scale performance. And ultimately, if the CPU performance isn't the limiting factor in your AI workload, perhaps having predictable performance matters more.
So if you want to go down to section 4, which is the section in this document that we're talking about, basically all the way at the bottom.
Yeah, there's 84 pages here, so don't mind the zoom scroll. Oh yeah.
Yeah. So now sort of going back to something you first said, this is the evolution of the core found in Grace. So the speculation right now is, so as we talked about previously in a prior tech routine about the ARM versus Qualcomm lawsuit, you need what's known as an architectural license agreement with ARM in order to make your own custom cores. The suspicion is that when NVIDIA failed to acquire ARM, one of the agreements
fallbacks
should that fail is that NVIDIA got a ALA or an architecture license agreement from ARM.
I think it was a 10-year agreement.
Yeah, a 10-year agreement to
build their own ARM cores.
Yep. What else is speculated And based on the layout of the core and what we know just from here, that NVIDIA may have also gotten the rights to edit, modify certain ARM cores. So they may have gotten, say, Neoverse V3 RTL or some sort of like agreement to be able to essentially edit pre-existing ARM cores, because quite a bit of this core actually lines up well with X925, with some similarities to Neoverse V3.
Well, so Grace was a V3 design.
Grace was V2. Was
V2.
Neoverse V2.
Okay, so Grace is Neoverse V2, yeah.
Yes. We don't know that for sure, of course, but that is currently what's being speculated, is that this is actually a modified Neoverse or Cortex core of some kind.
They did say that this core in Vera, the CPU, would be custom ARM, but custom in this case could mean slightly modified all the way through to clean sheet.
Like this is very much if this is like one of those cores, this is very much a very, very modified version. I mean, just by the fact that it has SMT, like it's not trivial.
We should point out this document doesn't have a block diagram, but it is telling us the latency of instructions and some of the capabilities.
It doesn't have a block diagram, but it does tell you the amount of pipes for each sort of scheduler, not scheduler, but for the core. So the amount of ALUs, the amount of load store units, the amount of
schedulers.
Not quite, because technically you can have multiple ports on a single scheduler. We'll talk about that later. But no, so it's not a fully fledged document, of course, but this does give a good idea about what the backend will roughly look like. And it actually tells you what the L1D latency looks like. It's 4 cycles.
That's pretty standard.
Yeah. So, but yeah, like I was saying, if this is a Neoverse or Cortex core, this is a very modified Cortex or Neoverse core.
Yeah.
Anyway,
the reason why we bring it up is because George pinged me and said this looks a bit weird. And it goes a little bit to my intro. It's different to how we see designs that we typically see in Intel and AMD, but also in other in any core that gives SMT, even some of the 4-way, 8-way SMT designs. And the reason why it does is because these tables here show some of the limits in the pipelines.
Yeah,
and so some of them are halved straight away, which indicates a statically scheduled part of the design.
Yeah. So here's what SMT is designed to do. It is designed to hide latency, right? So when you have let's say you have a thread that has to go out to memory, right? It has to go grab that could be hundreds of cycles. Well, in that case, you switch context, you go to the second thread, and you continue moving forward, and you're waiting for that memory on that first thread, right? So you can still do active work.
And if you can give more resources to the thread that's active, the idea is it should be faster.
Well, yeah. So you should be able to better feed the backend using this, using SMT, right? And this will still be able to achieve, this should still be able to hide latency. Maybe not as well as a sort of dynamic SMT implementation, but this should still be able to do it. But what a dynamic architecture, dynamic SMT does open you up to is more sort of security attacks. Now, at first I was thinking, okay, you would schedule it like this, right? You would have this sort of static scheduling in order to reduce the amount of security vulnerabilities you may have. However, if you see that fourth line, a conditional branch MOPS with dynamically changing directions, that means that you're still sharing branch units. And that makes
So that
me
kind of
suspect that they may still actually run into security vulnerabilities a la SMT.
So I want to point out for people who don't know how to read this table, right? Limit when one thread is running means how many resources you get when there's just one thread. So this is meant to be the peak of everything.
Yes.
So even if you don't understand what any of these pipelines used means, the whole idea is that all the individual structures inside the core, this is the peak. And for a dynamic, if you want your design to be fully dynamically scheduled, the idea is that the limit when two threads are running, which means that the limit of one thread when two threads are running, should be the same as what's in this middle column here. When it's halved, it means that there is a strict limit that when the core detects that two threads are running on it, it will.
I just sent you an image in Discord. I think this will actually show a sort of a good breakdown of what we're talking about here.
Yeah, that's one of the images I was looking for earlier. But the whole point is when you see these numbers and they're not identical, it means that there are fixed limits per thread when multiple threads are running. Let me adjust here. I need to add this.
Yeah. So now I am sort of so this is actually aside from Zen 1. But this shows, so competitively shared, basically anything that is a green is competitively shared. It's dynamic. Some may have what's known as watermarking, which is essentially a thread can only access up to, let's say, 80% of the number of entries for if you're running two threads, but most of these structures are dynamic. A couple such as the retire queue or the store queue or micro queue are statically partitioned, but very.
So in the Zen 2 version of this, most of it is red.
Yes, the only major difference is in I believe the store queue. The retire queue is statically partitioned, along with a couple other small things.
You mean things that stay the same, not things that changed?
Yes. But it is interesting that Nvidia. So for Nvidia, if you look at the sort of the bottom where it says AGUs, ALUs, mul add, those would be statically partitioned. So you would say get for you would have to pull it back up. But for the Nvidia architecture, it's instead of 6 simple ALUs, you only get 3 ALUs per thread, instead of being able to access all 6. What's interesting is that M0, or the complex number of pipelines, doesn't change. So if you're having, like, say, lots of multiplies or lots of divides, that's actually shared between the two threads, which is interesting. This is sort of reminiscent of, if you know, you know, the PowerPC E6500, where it had split ALUs per thread, except for the complex integer ALU, which was shared.
So overall, the way NVIDIA's core, if you imagine that this is, they'd just be more green.
Yeah, which is quite funny. And the difference there is your peak may not be as high, but your nadir, your troughs, shouldn't be as low. So what's interesting is, and it's really funny that we have Zen 1 pulled up here. Oracle, in their Zen 1, when they launched Naples, if you get the free tier, you actually got 2 threads on a Zen 1 core, but they flipped a chicken bit. And that chicken bit splits the core in half.
Oh, so it's fully static.
It's fully static, completely all the way down, if I remember correctly, which is very interesting. So they flipped that chicken bit. Now I think follow-on Zens have that same chicken bit, but I don't know of any implementation that's flipped that.
Quote unquote semi-custom. So semi-custom could literally be 1 bit.
Yeah.
In that case.
So x86 CPUs have had this capability. Should the customer want it? And it's interesting that this is sort of the default for NVIDIA, not sort of an option. Like,
so one of the things is these cores that AMD and Intel make, and also AMD and Intel make, they have to go into everything from notebooks to consumer, where peak bursty workloads matter, right? Where sometimes the data isn't regular loading a game. So being able to push a bit higher in IPC on a single thread matters. These are going into Vera, which will be paired with Rubin. So they're doing AI backhaul work where peak performance isn't needed.
Well, so then the question becomes, will NVIDIA make a Vera C1? So with Grace, there is a version of Grace called the Grace C1, which is a single Grace chip on a PCB. It's basically just a standard motherboard with just a single Grace CPU and its memory, and that's it. Like nothing else.
It's meant to be designed for workstations.
No, actually, it was designed for Google. Sorry, not Google, Amazon. I mean, it was both. But basically, what they did was they essentially deployed these as the edge processor because they didn't want to deploy their own silicon. They didn't want people to be able to access it. So,
so let's use something that everybody can quote unquote access anyway.
Yes,
that's at least somewhat similar to stuff that we know and is easily portable.
Yes. So the question is, will they have a Vera C1 version? In which case,
could things change?
Yeah, I like to. Then it's just a standard CPU that's doing CPU things, right? So
yeah,
it'll be interesting to test.
Well, also this document is from August.
Yeah, although I don't suspect that this has changed.
Yeah, this would be a bit hard. Well, again, going back to your chicken bit idea, if there is a chicken bit to make it more dynamic, then maybe they just flip that by default. So yeah, and as Josh says, edge processing for hyperscaler isn't that burstier workload either. But also don't forget the high core count cloud-based CPUs that the hyperscalers use. This could also fall into that, maybe. As long as it's not just another memory controller vehicle.
I mean, inevitably, that's what it's going to be in the Vera Rubin.
Well, we'll see how much more of a mixed CPU GPU workload AI becomes, right? So,
yeah, actually, we it's funny because we were talking about that at Barvel's Analyst Day.
Yes. Yeah.
Sorry,
go on.
No. I was just gonna say, and you get different answers depending on who you ask.
Yeah. So let's move on to the next topic, which comes from our good friend IntsLatex.
Instruction latency x64.
Yes.
So AMD released the first official Zen 6 document, performance monitor counters for AMD family, a 1AH model 50H-57H. These are hex processors. So they've confirmed that it in fact supports FP16. We also know that AMD, it supports the AVX 512 FP16 ISA. Interestingly enough, Zen 6 also brings, for the first time in a very long time, a ISA of AMD's own making, as far as we can tell, AVX 512 BMM, which is for bit multiplication and bit manipulation. And it brings a new memory profiler for improved profiling of memory, should you want to read like how your system is performing, what bottlenecks are you having, good stuff like that. And most interestingly enough for this conversation, 6 integer schedulers instead of a single unified scheduler that Zen 5 had. Now, this is very interesting because I think we were all sort of expecting Zen 6 to be an incremental, like an evolution of the Zen 5 architecture.
Just hitting the low-hanging fruit in the design. And just micro optimizations. It's whenever we ask any CPU architect, they say, "Are there things you would have done differently if you had 2 more weeks?" And they're like, "Oh yeah, you've got to, at some point you've got to close the design and send it to the fab." But you always, find edge cases or things that you can do that typically get rolled out into, might be the refresh or the next spin or, the sort of stuff that used to be just in the next spin, but now actually becomes a new product line, sort of thing. So and AMD's been doing the clean sheet update, clean sheet update, clean sheet update for a few years now.
And to that point, the even generations was sort of the evolution of the prior generation. So Zen 2 was an evolution of Zen 1, Zen 4 was an evolution of Zen 3, and we were expecting Zen 6 to be an evolution of Zen 5. And it's very likely that that is still the case, but this seems to be a bit more than just sort of what we saw. This seems to be a bit more than just being iterative. Zen 3 to Zen 4 was, for the most part, a fairly iterative design, with the new additions being, you could call quality of life, sort of new instruction sets, slightly bigger core, but was largely very, very similar. You could see the similarities from across the room. Whereas Zen 6 looks to be more like the move from Zen 1 to Zen 2, at least as far as the schedulers are concerned. So Zen 1 had 6 independent schedulers, 4 for its ALUs and 2 for its AGUs. It's not shown here, but and then Zen 2 changed that so that there's still the 4 ALU schedulers, and while this diagram doesn't show it, those 3 scheduler blocks was actually a single AGU block of 28 entries. Zen 3 changed that. They then moved to a sort of a unified AGU and ALU scheduler, and they had 4 of them, 1 per ALU. One of the schedulers was ALU and branch unit. So not all of them could do AGUs, but stick with me here. Zen 4 kept that exact same scheduler design. They didn't even change the entries, if I remember correctly. And then Zen 5 moved to a single unified ALU scheduler and a single unified AGU scheduler.
So in this diagram, we're looking at the blue box, and you see where it says integer scheduler, we have 2 schedulers. One serves all the ALUs, and one serves all the AGUs. Right, so that's the arithmetic logic units. They're the ones that actually do the calculations. and the AGU, that's the address generation units, that's doing all the memory table lookups.
Exactly.
And
so what it looks like with Zen 6 is that they've gone back to a Zen 3/Zen 4 like design, where the AGU scheduler and ALU schedulers are actually unified, and there's 6 of them. So there's 6 independent schedulers that will be able to do AGU and ALU operations. Now, we don't actually know the port arrangement. I do assume that it's still 6 ALUs. That does seem...
So instead of it being a 6+4, it's now a 6+6. But it's not really a 6+6. It's a 6 multiplied by 1+1.
So the thing is, we don't know the AGU layout. I would not be surprised to learn that they have moved to 6 AGUs, which then brings up the question of, well, how could you do 6 AGUs, right? Because you can have AGUs that just do loads, you can have AGUs that just do stores, or you could have AGUs that do both loads and stores. In the Zen 5 architecture, you have 4 AGUs, 2 of which are load only, and 2 of which are load and store units. So you can sync this up as saying the Zen 5 core can do 4 memory operations, of which any 2 can be stores.
And you do have to wonder what workloads would benefit from increasing that from 4 loads to 6 loads, or some other combination.
So the sort of 3 combinations, although one of them is less likely, that I can think of is 6 loads, of which, or 6 memory operations, of which any 4 could be stores. So 6 loads, 4 stores per cycle. You could also do 6 loads and 3 stores, but I don't find that very likely because of the AVX512 behavior, but I'll talk about that in a second. And the other option is 4 loads and 2 stores, and that's your lot. You just have 4 load AGUs
so they
and 2 store AGUs.
They fully become fully independent and have their own pipes.
Yes, that is a possibility.
Because when you're in an environment where you need to do 2 stores per every cycle, your loads are also limited to 2. But by splitting them out, you could also do 4 loads per cycle at the same time.
Not necessarily. You should still be able to do the 4 loads and 2 stores. Not
in Zen 5.
Yes, you should be able to do 2 loads and 2 stores.
No, 4 loads and 2 stores. So I'm saying.
Yeah. You can do 4 memory operations, of which any 2 can be stores.
Yes.
So you could do 4 loads, or 3 loads in 1 store, 2 loads in 2 stores.
It's what I said is, if you're in an environment where you're doing 2 stores every cycle, you're limited to 2 loads.
Yes.
There may be situations where you need to do more than 2 loads per cycle, because modern workloads tend to be more load heavy. That's why we already have a 4-2 split.
Yeah.
It just costs power and die area.
Yeah. The sort of the first. Yeah. The first configuration could also do that. It would be 6 loads, 4 stores. So it could do like 4 loads and 2 stores, or 6 loads and 0 stores, whatever combination you want. But the reason why I say that the sort of 6 and 3 is not really feasible is because AMD's AGUs are, somebody's going to yell at me for this, but for the general audience, this is fine, are 256-bit wide pipes. So for 512-bit operations, you're essentially using 2 of the AGU pipes.
Simultaneously, yeah.
It doesn't quite work like that, but give me a little bit of slack. So with that, if you have six loads, you can do 3 512-bit loads at any given time. But with 3 stores, that means that you have to do 1.5 stores per cycle. And then that then brings up the question, is your store queue 256-bit or not? And it just kind of becomes weird. So I suspect
maybe only 2 of those store pipes could be used for.
That is possible.
We've seen it in the past where certain pipes are only limited to certain types of operations.
Yeah. So it would be a little bit weird. So I kind of suspect that we'll see either 6 memory ops, of which any 4 could be stores, or 4 loads and 2 stores. I suspect that would be the layout that AMD would go with if they're in fact going to 6 AGUs. Which we're not positive about.
But this is Venice. This is Zen 6. So this is going to be AMD's big CPU launch in 26.
Which so actually, I guess that sort of rolls well into our next topic of CES.
Yes.
Lisa Su has the presiding opening keynote at CES. Do you expect there to be a Zen 6 performance teaser?
No.
I
want to say we're too early.
I will say I was surprised when they showed off Venice performance numbers at Advancing AI.
Did they?
Yes, they did. 1.7x performance. Top SKU.
You're okay. No, you're talking about high level.
Yeah. No, I'm talking like
numbers.
What if they they show off like sort of like the Zen 4 preview that they showed, where they had a clock locked comparison. I think it was Zen 4. Anyway, a clock lock comparison versus Zen 6 versus Zen 5. Do you think we'll see that, or do you think?
With my analyst hat on, I wouldn't see much value out of it. But I could see for drumming up interest, there might be. Because I have to think, right? What else is AMD going to talk about at CES, right? We're mid-update cycle for pretty much everything right now.
Yeah.
Right. We're not going to get new GPU stuff. Okay, there might be some stuff about Redstone, that just came out. There's nothing on the AI GPU side. We know MI55X, we know MI400. They might start talking about some numbers, some deployments, some partners.
There is potentially one thing that was, I have a sneaking suspicion that they may do, and that is a PCIe version of MI400.
Is that really headliner news? Again,
no, not no. That would sort of be like a one last thing.
Yeah. Mobile updates. Are we going to get iterations on Strix Point?
I would expect so, but
what? We're too early for Zen 6, so it would be a Zen 5 refresh.
Yeah. So which then brings up the question: why are they trotting out? Why is Lisa having that?
So I will say that official keynotes are 45 minutes, an hour. The unofficial the unofficial ones can be 2 hours plus.
Well, Jensen's last year was over 2 hours.
I know, but that wasn't an official one though, was it?
It was the headliner. It was the opening keynote for CES.
Is that the end of the day one though?
Yes. It's the same one that Lisa has.
Okay.
Lisa's keynote is 1 hour and 15 minutes.
Yeah, so it's and chances are that's also going to be full of partners and stuff. coming on as well, because So realistically, could they put out some Venice numbers to make a bit bigger of a splash? Yeah, I could see that.
Yeah, I actually suspect that they may show like desktop. They may like sort of, because the rumor is that Zen 6 will have 24 cores. They may announce that. They may also show like clock lock gaming or something, like something that sort of you could tease fairly safely.
So I think one of the big things is going to be just Helios. Okay, they showed Helios off at kind of like an advancing AI, but then at OCP.
Yeah, OCP was the big launch.
I know, but this is much more of a wider audience than OCP.
True.
Right. OCP, you're in the industry. This is for if you're in technology, regardless. Actually,
so Jay says in chat, surprise Medusa Halo launch. They may not. They will not be launching Medusa Halo, but what they may show is a roadmap for like.
Which one's Medusa Halo?
That's the replacement for Strix Halo.
Okay. What, Zen 6 based?
Zen 6 and rumored to be RDNA 5.
Okay. Rumor. Yes, okay.
Yeah, I mean that's all we have.
The reason why we didn't put rumor hashtag whatever on the Venice performance number stuff is because that's literally AMD's guide.
Yeah.
Right.
AMD said 1.7x performance.
No. I mean the scheduler thing.
Oh yeah, that's literally AMD's performance monitoring.
Yeah. So
counters.
It's I mean, so AMD's keynote is on January 5th, the Monday, which is going to be a very, very busy day, because Nvidia has their event from 1 p.m. to 2:30. They've got an hour and a half. Jensen, they're calling it NVIDIA Live. And the funny thing is, I didn't get an email or anything from NVIDIA saying that they were doing it.
I didn't get anything either.
It's because I saw somebody else's stream and they brought up nvidia.com, and have I lost everything? Yeah. So NVIDIA Live with Jensen. So yeah, that's at 1 p.m. 1 p.m. to 2:30. Doors open an hour and a half in advance. That's at the Fontainebleau. And it looks like they have their usual showcase and on the 4th floor of the hotel. So that goes until 2:30. Then we have Intel.
Yeah.
At 2:30.
I should probably put that. That's on the 5th, right?
Well, yeah, no, this is still same day. Let's yeah, in Intel at CES. So, oh no, they've changed that. They've changed the time.
Oh, have they?
Yes. Okay. This is the Intel website. What's that?
Yeah, that's a Panther.
Panther Lake. So all the Panther Lake news. That's at 3 p.m.
Okay.
So Jim Johnson, who's ahead of the client computing group, or the GM of the client computing group, yeah, we're going to see some Panther Lake launch official. So this is where we're actually going to see products and performance numbers and a lot of that. That's so that's Nvidia at 1 p.m. Intel halfway across Vegas, so traffic's going to be terrible, at 3. and then AMD is at 630. Yeah, 630, but that's in the Venetian, so it's at the same location as Intel.
Yeah.
So you have to decide. Are you going to all three, or are you going to choose two and just have a more comfortable experience? I'm pretty sure everybody's going to go to AMD's because that's like the end of the day. And if you're just coming from Intel, it's literally upstairs.
Yeah.
Whereas if you're it's the Nvidia Intel thing. It depends who you're covering more, or in my case, who's your client.
Yeah.
So, or if you have meetings already booked for that time because you didn't know what was going on because nobody emailed you. Yeah.
Is it Delfino for Intel?
Yes. George is updating his.
Yeah, I'm literally
already.
updating my calendar.
It means that there's going to be a lot of. So for anybody who's not attending, I believe all three of these are going to be live streamed.
I would be shocked if they weren't.
Nvidia's definitely is. AMD's definitely is.
Intel's
is it?
Yeah, I mean, you just had the video right there.
Oh yeah, it says launch event live stream. Well, no, it wasn't a video. It was just a link. So yeah, so they're all going to be live streamed. We're going to end up being at all of them.
I may skip Nvidia's just because I don't want to have to run through, especially if I'm going to be considering how much running around we're going to be doing on the 5th. If my foot is killing me, I'm not going to be running to Nvidia. Like, I'm going to just stay at the Venetian because and just watch it on my phone. So to any Nvidia reps that are watching, if I'm not there, I do apologize.
Or go for half an hour. And hopefully there won't be one more thing that Jensen announces.
Hopefully. Or I could just watch on my phone.
Or hope there's a pre-brief.
I haven't gotten anything from Nvidia since.
Well, even if you did, you couldn't mention it.
Yeah.
So there is that.
Yeah.
But yeah, okay. So if AMD is going to have some stuff, Intel's main thing is going to be Panther.
Mm-hmm.
What's Nvidia going to talk about? Groq.
So the assumption was that they were going to talk about like 50 series Super, but sort of referencing back to last week with the memory crunch that's going on, does Nvidia even want to launch that right now?
Did you see was it a Chinese forum report that that Gamers Nexus, WCCF, I think even Paul's Hardware has picked up that they're going to be reducing throughput. Reducing manufacturing cards by 30 to 40% for consumer.
Oh yeah, I saw that.
Not confirmed, by the way.
Yeah.
Industry sources, i.e., we overheard somebody in a bathroom, which used to be, what happened in Taiwan back in the day.
Yeah.
It's and the problem is, I think people don't understand how the memory industry works. You can't just use. I saw a video where somebody correctly highlighted where you can't use DDR as GDDR.
Mm-hmm.
And I think it was like a YouTube video or a short or something, and the person said, "Well, no, technically you can't, but they are of a similar technology, so it's pretty easy to adjust." And I'm like, no.
Like, yeah, they use similar nodes, but you can't just
instead of making a wafer of this, you make a wafer of this. Sure, but if you have to, if you're doing different steps with GDDR or HBM versus DDR, then you need a different ratio of machines to do that.
Yeah. Now, as far as I understand it, in terms of like actually like manufacturing, LPDDR and DDR are actually fairly intercompatible in terms of like tooling count and stuff.
The process is slightly different, but yeah.
Yeah. GDDR is a bit different in its mix, not a lot, but a bit, as far as I understand it. And then HBM, while it uses the same dies as DDR, has added packaging, and that needs a different set of tools.
It's different. It's different enough to DDR now as well.
Oh, is it? I thought it was still using the same base DDR die. Okay.
No.
Okay.
No.
Because I know they used to. I know that used to be the case.
It's when you start packaging them 8 high, 12 high. Okay. You need to take into account different thermal characteristics.
Okay.
Yeah, so you could think, well, instead of doing a wafer doing this, to have a wafer doing that. And I'm like, there's actually, logistics to doing that. And yes, some of that is possible, but, do you increase your GDDR output by 10% to hamper your DDR5 by 20?
Yeah.
Right? But it's that sort of thing. There is an optimal throughput. And yeah, everybody's building more facilities. It's my same argument that I did on the last Poutine with Micron. Crucial pulling out. It's like that memory is still going to exist in the market.
Well, I was literally having to like explain to somebody that the memory that you buy on consumer DDR like this is no different than the memory that you buy. Like the physical memory chips are likely no different than what's on like an RDIMM for server.
Correct.
Like, unless it's a different like IC revision, which is meh.
No, well, chances no, they build it in.
Yeah.
Right. So just some bits are turned off for non-RDIMMs.
Exactly.
Things like voltage control and monitoring stuff. Yeah. Shai says, waving you're flashing the cash.
Yes,
George.
My 8 gig stick of DDR4 is totally worth. Yeah.
Yeah, the vengeance. Yeah. So it's
actually I had a funnier stick somewhere that was a DDR2 stick that was blue. That would have been really funny to be waving around.
It's the whole people are getting mixed up between prices going up and supply. Prices are going up because of demand, not because supply's changed. Right? Supply hasn't gotten worse. There hasn't been a fire in a fab somewhere that's ruined 6 months supply. It's not Ajinomoto build-up film that happened years ago. It's not the Thailand floods that decimated the hardware industry for years. Hard drives, yeah. So it's
the only memory that we can afford now.
Is that DDR3 1866?
It's DDR2 800.
Yeah. So it's yeah. Coming back to Nvidia, it's the whole thing about reducing consumer CPUs. I could see it, or it's GPUs. I could see it more as a function of, well, the market just doesn't make us enough money, but it's still 10% of the business. It's still 10% of the revenue, right? Or 8% or whatever it is now.
And if you think about it from the perspective of free cash flow versus like the percent of the business, like even if Nvidia lost like 80% of the data center business today, they would still be, I think, cash flow neutral.
Oh yeah, and they'd still be making more than gaming. And
no, I think they would be making just about as much as gaming if they lost 80%.
It's
no,
it's
you're right. No, yeah.
I think the question becomes more of how many silicon dies is Nvidia ordering of the mid-range chips, right? The 3 class, the 5 class, the 7 class. Because that ultimately is going to dictate how many end up in the market, right? You could say, oh, well, they only want to tackle the high end. Well, you also have bin downs to deal with. And would Nvidia rather use that supply for Blackwell dies? Sure. If there's capacity to package them, if there's other supply chain capacity to do it. In terms of what they might be announcing at CES, let's just get back on track for a second. Because CES has historically been a little bit of an automotive conference, and, even though it originates from Consumer Electronics Show, I've got a feeling they're going to push hard into 2026 being the year of robotics.
Almost certainly, yes.
So they're going to be pushing hard on what they see as the next frontier of revenue. Jensen will spend half an hour talking about data center, no doubt, right? Reiterating Vera, reiterating Rubin, talking about the improvements they've done in the last 6 months since Computex, reiterating what they presented at GTC Paris and GTC Japan, because those are things now. And then just saying, more one foot in front of the other. I don't expect we'll see roadmap updates on silicon. Just because they're if they mention Groq, I'd say I'd be surprised, but Marvell spoke heavily about Celestial a couple of weeks ago. And did you see that iRobot has filed for bankruptcy?
Yes, I did.
The Roomba, the company behind the most popular brand of Roomba. So, it's so more robotics, perhaps. They've done like the Lucasfilm BB-8 tie-in before and things like that.
Yeah,
it's that's what I expect to see at CES from them. And I don't know how your CES schedule is looking so far. Most of mine seems to be drinks.
Yeah. That's basically most of my end. Most of the end of the days is drinks. Yeah, my CES schedule is nowhere near as packed as my supercomputing schedule.
I've kind of been putting off booking my meetings until I was done with Marvell and IEDM, and then last week I was just super busy. So I've got a few evening things planned, a few client meetings. For anybody going to CES, I think I've said this before, but there are 2 main venues, right? There's the Convention Center and the Venetian Palazzo. The Venetian Palazzo in general is relatively okay to go through, easy enough to walk through. There is some it's the Venetian, the Sands stuff that can be a bit busy, but that's more component side. At the convention, there's 3 halls: North Hall, West Hall, South Hall. Avoid South Hall like the plague.
Unfortunately, I'm going to South Hall.
If you can get transport to North or West Hall and going through there, and North Hall is usually automotive focused, or at least a good chunk of it, and West Hall is a bit more IoT or just more sort of general tech stuff. They tend to be more traditional trade show if you're just there to walk around or see people. Whereas in South Hall, you'll see people packed like sardines to the point where instead of sneezing into tissue, they'd be sneezing in the air. And it's the source of most illnesses post CES. So a lot of companies, a lot of the traditional PC component companies aren't in either of those places. They have their own showrooms in different hotels. And because it's a trade show, not a public show, you need a meeting to get into them. So if you want to go see Mushkin, for example, or companies like that, or case companies or power supply companies, they typically have suites in MGM and Luxor and what have you. Whereas in the Venetian, in the meeting rooms there, you're going to have MSI, you're going to have Cadence, you're going to have ARM. Our friends at Frost Systems are usually there. Acer is usually there. In the little walkway between, you're going to have the Lenovo area. That's usually there. And sometimes you'll even see some of the press. Some of the big, like The Verge or Engadget might have their own dedicated, or Wired have their own dedicated area in some of these places. And yeah, it's and it can get quite busy. I think I'm scheduled to be at the convention center on the Wednesday, and then the other 2 days I'll spend at the Venetian.
So the Thursday, I'm going to be at the convention center.
The goal is, if you're ping-ponging between lots of places, try and have the same company in the same location at the same time.
Yeah, so
you just don't be going from Bellagio down to the Monte Carlo, back up to the Bellagio, back down to the Monte Carlo.
Or so I know somebody who was thinking, who scheduled a whole bunch of meetings. They went from the Bellagio to LVCC to Fontainebleau, from LVCC to Venetian to Fontainebleau to Caesar's Palace. Which, for any of you who know and then they ended at Mandalay Bay. That is the entire strip, right?
The key with Vegas is, if you think you can walk it, you can't.
I've done that walk before in 100-degree heat, 100-degree Fahrenheit, like 110-degree Fahrenheit heat. Don't do it. Do not do it.
Because most roads that you have to cross, you actually have to go up an escalator, through a casino, over a bridge, through the casino, into another casino, then back through the casino. And sometimes these casinos take 5 to 10 minutes just to walk through. So it's unless you can literally see the path across the road,
don't walk it.
Or if you, I do know people who like schedule an hour between meetings so they can, and that's fine. It depends how dense you want it to be. At least Uber is a thing now.
Yeah.
Pre-pandemic, it was all cash-based taxis that didn't take card.
Yeah.
But now, and also the queue outside the Venetian would be several hundred, if not 1,000 people, and it can take you 45 minutes to get a cab. Whereas I think you just go downstairs and there's an Uber line, and it's like you would get an Uber at an airport. It's very easy. And I'll try not to damage my trousers this year. Outside the Venetian, they've got curbs that are, I don't know, a good foot tall.
Yeah.
And I wasn't looking properly, thought it was a regular curb, stubbed my toe, and then started to fall over. And I was like, okay, so bring my other foot to come up and over, but I didn't bring it up far enough, and I stubbed my toe again while carrying a big backpack. Buses are irregular, and I once got stuck at an intersection because a bus tried to turn right or left or whatever, ended up blocking the intersection for 4 changes of lights. So we spent we would literally.
You can take the monorail.
Which
runs. I think it's what,
on the west side, isn't it?
Yeah, it's west side, and it's sorry, no, it's east side. Yes, it's
No,
east
no.
side.
I thought there was one that went from Monte Carlo through Excalibur up to the Bellagio.
Yeah. So there's that one, but I'm thinking the Las Vegas monorail, which is different. No,
that's like
there's the
$25
left
for the
side
week,
one.
isn't it?
Something like that. Yeah, it's not too bad.
I've never taken it.
I have taken it. It's not terrible. But the issue with that is that you actually don't get dropped off at the Venetian. You get dropped off
At the shops.
No, you get dropped off at I can never remember. It's either you can get off at MGM Grand or Flamingos. What used to be Flamingos.
Or is it not Harrah's?
Oh yes, Harrah's. Thank you. And then you have to walk to.
Yeah, it's Harrah's, which is you don't have to go through the link.
Yeah,
and Harrah's to get to the Venetian, to get to the plots. Or yeah.
Well, the Palazzo and Venetian are functionally one hotel that are just connected.
Yeah.
So yeah, you can do that. It's just a little bit more of a pain in the back end.
And if you're really unlucky, you go visit Asus at the Trump.
So Asus is at the Venetian.
Oh, okay, so they've moved out of the Trump. Okay,
yeah,
I do like the fact here that they've made it incredibly tiny.
Yes, they've almost certainly done that on purpose.
Yes.
So CES is so big that so they do run shuttle buses. That's the thing. They do run shuttle buses. You know that, right? Between the Venetian and LVCC.
Yes. Though those can take 40 minutes in traffic.
Yep. And most of the traffic is just getting into the freaking LVCC.
This is why you say you go to the north, or you go to the West Gate.
Yes, and you can take Westgate and walk in.
So people looking on the screen now, down here is Mandalay Bay, or what used to be the Monte Carlo.
No, the Monte Carlo was up north. It was over by TI.
Are you sure? Because I remember staying here, and all the way up here, it's what, about 3.5 miles end to end.
Something like that, yeah.
Yeah. And I don't know if you can see my mouse on the screen. So you've got right by the Sphere here is where the Palazzo and Venetian are. Top right is where the convention center is. And bottom left, opposite the Allegiant Stadium, Mandalay Bay, that's where the keynotes are. Or that's where the keynotes usually are.
So, yeah, luckily the Intel and AMD ones are in the Venetian. Where you're staying in the Venetian, I'm at Planet Hollywood, which is just south of Paris, or the Paris Hotel
down here.
Yeah.
There's the F1 paddock. If you want fast internet, and I say this because I know the Venetian's terrible internet, stay at Virgin.
Yep.
And I say this because Intel had one of their events in Vegas last year, Intel Vision, the analyst and customer one. That was at Virgin, and they had 300 meg symmetric.
Oh, nice.
So I'm being invited by Intel to attend. They're flying me out, and I'm attending their stuff. If I was paying my own way, I'd be staying at Virgin probably. I have seen how much they're paying for my room, and it is eye-watering. But Vegas is eye-watering. When I traveled with Future, an Antex publisher, They went from a 75-day per diem budget to a per meal budget, to which $15 for breakfast got you an orange juice. Because Vegas.
Well, that's gotten Vegas. Yeah,
that's Vegas during an event money.
Yeah, Vegas is. Yeah.
The just plan ahead.
Yeah.
It's well, I mean, I land and then 2 hours later I'm in a meeting. So
luckily I land and then I don't have anything on the 4th at the moment, but I may want to meet up with some folks like Sasha or whoever's doing a thing.
Well, they might be busy prepping.
Yeah.
And we also have to find a time to do a live Poutine.
Yeah.
So
actually
that might be on the Thursday.
That works for me. I was gonna say Thursday or Tuesday afternoon.
Or we could do it just Monday after the keynotes and cover the keynotes.
Oh, so like at 9 o'clock, 9:10?
Or whatever's going on, yeah.
Works for me.
Oh, and Wildcat says, is Ark dead? No! Stop believing Tom.
Oh my god. You saw it. You know what I'm talking about.
Yeah. Yeah, when somebody who creates their image all around leaks turns around and says, verify your sources. Yeah.
Yeah.
It's fun. Okay, cool. I think we're out of topics. The Groq Nvidia thing was my big thing. I didn't get to bed until 2 a.m. on Christmas Day because of it. But my article did blow up. I was third on Rising in Technology on Substack.
That's neat.
Our good friend Austin Lyons was 7th, and Vikram Sakar was 10th. It just means you're small but you're growing in size, and got quite a few subscribers from that post. So sometimes working at midnight on Christmas works. So yeah, and on the Tech Potato channel, just so you know, we've got a bunch of videos upcoming. A number of them are sponsored, but they're pretty cool sponsors, talking about some really interesting stuff. I may be doing a stream later this week of celebrating Chemistmas. So most of you know I am a chemist historically by education. And so I have developed a little web app to help me do some chemistry ASMR for a live stream. It is glorious. It is vibe coded.
Oh boy, Ian.
I have to decide the exact way I'm going to do it. But yeah, if you're interested in listening to a British person,
is this because of what happens after the last Tech Poutine?
No.
Okay.
No. It's I've got a long list of chemical names to reel off, and it's very fun.
Because you were doing that after the last Tech Poutine.
Oh no, it's based on that.
That's what I was
based
thinking.
on that. I sent you a mini video.
Oh yes, you did. Yes.
Okay. So stay tuned for that. It's going to be fun. Okay, cool. Well, thank you, George. Thank you, everyone, for taking part. We'll see you. We'll have the next Poutine at CES, unless somebody
unless there's
retires or
news,
dies. Or,
unless there's major breaking news, we
also have to do prediction stream.
Oh, predictions of
Because
what's at CES?
we made predictions for 25.
Oh yes.
We have to go back and remember what our predictions were and see if we win.
Yeah, I don't even remember.
And see if we can make any 26 predictions. It never ends, does it?
No, I mean, I could not have made November and December predictions in terms of like mergers and acquisitions. So much stuff happened.
I think Q4 was just crazy.
Yeah. Q4 was just utterly nutty.
But Q1 has Chinese New Year, and that usually quietens down.
Yeah.
Yeah. It means we can catch up with stuff.
Yeah, which is good because frankly, I haven't even had time to digest some of the news that came out.
So I will say, for those of you who remember me back at my Anantech days, one of the junior writers there was a guy called Gavin Bonshaw. He's now doing some work for me.
He's also doing work for another UK publishing. I saw on LinkedIn.
Oh, he has done some work for the Register.
No, not the Register. EDO Tech.
No, that's just a mate of his.
Oh, okay.
Yeah. So, yeah. So, Gavin's got a couple of projects on his plate from me. So, if you're interested in seeing some of the content, then it's going to be on the Substack. Josh, no, you're thinking of Ryan Smith, not Gavin.
Yeah.
Ryan now has a job at full-time job.
He's now managing editor of Surflong.
Yeah.
I wonder how that's going. I should probably ask him.
Well, it's only been a couple of weeks and it's been Christmas, so.
True.
Yeah. Ask after CES.
No, not Ryan Shrout. Ryan Shrout.
Ryan Smith.
Ryan Smith, not Ryan Shrout. Ryan Shrout works at Signal 95. Signal 65. Excuse me.
Which I keep thinking is System 65.
Yeah, but that's actually System 76.
Yes, exactly.
Too many numbers, too many.
Which is actually 476.
Yeah.
Yeah. Pick company names that stand out, people.
Chips and Cheese, More Than More, Tech Potato. Yeah, people are like, I love your name. Like, why do you pick that name? It's like, because people remember it. Like, it's not.
It's the same with the Poutine.
Yeah. Like, you need a good name.
Apparently, in some parts of Eastern Canada, there is a group of people who regularly meet, like a local electronics group or something, and they call themselves the Tech Poutine as well.
That's funny.
So, Toronto, Montreal, or something thing. So, as you might expect.
Do you want to do a single 2026 prediction, or?
Oh, well, I was going to say no tachyon silicon, but we know that.
Did you ever watch it? No.
No, I got cringe before I even. Yeah. So. Jay, ping me on Discord. All right, then I'm going to go get some dinner.
Yeah. And it's soon to be lunchtime for me, so.
Take care, everyone.
Have a good one, folks.
If you like this content, there are multiple ways to support the channel. You can like and subscribe this video, and many thanks for doing so. There's also a Patreon, which gives you access to our Discord. There's a merchandise store and a newsletter, links in the description. For all of you who do contribute, thank you. You are keeping me well fed.